All right, once again, warm-up number 95. Oh my goodness. Yeah. All right. So, I don't know what's going on with my computer. It's glitching, so maybe we won't have a lesson today. Not. Anyways, warm-up 95, if you notice, number 1 is exponentials. We already talked about those. I'm going to elaborate on those a little bit. Number 2, you should be able to do by yourself, as well as number 3. But I am going to elaborate on 3C. And number 4 is the notes that you took by yourself during my absence. Pretty good, right? And I'm going to elaborate on number 5. So here goes number 1. Let's see. Should be just about done with number 4 by now, yes? All right, here goes number 1. If we distribute this, this is 3 to the negative 2, which we can't have a negative, right? And what do? The reciprocal, so this ends up being 1 over 9. Is that correct? All right. If we distribute this exponent as well, this is 1 to the negative 3rd over 3 to the negative 3rd. We do the reciprocal, so we end up with 9. Is that correct? Okay. Let's look at 1C. This one's already simplified, but they want us to rewrite it, which means we need to bring it back to the way it was. So question. This is a factor. If this was inside of the square root, think about that. What number, if you take the square root, gives us 3? What number, if we take the square root of that number, gives us 3? 9. So that means this is square root of 5 times square root of 9. That is correct, because that gives us 3. Square root of 9 gives us 3. So when we have two square roots as follows, we can write it as 1 by multiplying those numbers. So what is 5 times 9? This is square root of 45. Okay. Next, this one right here, this can be rewritten as 2 to the x times 2 to the negative 3, and of course this is 2 to the x over 2 to the 3rd, which is 8. Yes, I gave you like plenty of practice on the warm-ups with that one. Okay, good. Let's look at number 3. This is, this should have been covered in Algebra 1. I'm just bringing it back for some of you. Whenever they give us an exponent of one fraction, but with the numerator of 1, that means this becomes, when it's a 1/2, this becomes a square root. Square root, that's what 1/2 means. So this is square root of 81. What is square root of 81? 9. Okay. Now, why is it square root, Mr. Q? Because this denominator, look up, the denominator of 2 is the index here, or the number that tells us what number times itself that number of times. How many times? Twice. What number times itself twice gives us 81? 9. So we can do the same thing with this one. Take the square root of 100, or this one is the index, so what number times itself 2 times gives us 100? That is 10. Okay. All right, but that leaves us with a little dilemma with number 3C. So let me erase this over here. Let me make some space. And let me zoom in. So if you notice, this one is not, there is no 1 on the numerator, right? So that means I need to rewrite this in a way that we have a fraction with a numerator of 1. So how can I rewrite this? 1/3. Is that correct? So what do we do with that 2? We just write it to the side. 2 times 1/3 is the same as what? 2/3. So now we have 8 to the 1/3 times 2. Okay, so if this was, look up, 100 square root with an index of 2, that tells us what number times itself 2 times gives us that, what do you think this would be? Yeah, with an index of 3. So cube root of 8. Cube root of 8. And all that in parentheses, and what is the only thing that stays outside? The exponent of 2. So question. What number times itself 3 times, that's what this means, gives us 8? 2. So this is 2. And what was our exponent outside? 2. So what is 2 to the second? 2 to the second is 4. Right, man. And once again, this is an Algebra 1 concept. Your teacher should have covered this, right? They better. Oh, yes. I remember we hammered this pretty well. All right. Let me zoom out. Let's go to this one. This is an exponential, and today we're going to revisit that. And I said, just use 3 points, 0, 1, 1, 2, and 2, 4. However, this is going to move in which direction? Tell your neighbor, please. Where is this going to move to? Very good. 2 to the right and 1 up. 2 to the right, 1 up. So that means 2 to the right, 1 up. So my new one should be right there. I'm going to revisit today that session. Today, like I said, I'm going to compress 2 lessons in one just so that we can move on. But I do want to get to our trig functions. And once again, students, trigonometry students, or pre-cal, whatever you want to call it. All right, so here we go. You're given this right triangle. So let's first make sure we know what we see. Here's a 90-degree angle. Does everybody see it? The side that is right across from it, this one, the wiggles on it, this is what we know as the hypotenuse. Hypotenuse. And the other 2 sides are just known as sides or legs. The letters, how many letters do you see? 3, correspond to the angle, not the side. Let me repeat that again. Correspond to what? The angle, not the side. So which angle are they asking us to focus on? Angle what? A. So this is what I want you to do. I want you to circle the letter A, but including the angle. Look up. Like this. So like that, it forms a little angle right there. So let's begin. They want us to find sine. So you write sine equals fraction. So let's see the instructions. It says, oh, and I'm going to write, I forgot, hold on. Sine angle A. Sine for angle A. All right, so let's see. What are the instructions? The instructions are sine is opposite, and this is what we call, all these are sides. Sides, not angles. These are sides, all of these. These are angles. Let me repeat that again. These are sides, these are angles. Okay, so opposite side over what? Hypotenuse. So let's see. Here's my angle A. What side is opposite to A? This side, is that correct? That's all the way on the opposite side. So that means I'm going to write 3. What is a hypotenuse? 5. Therefore, this becomes 0.6. That's the sine of angle A. Go to the next one. Cosine angle A. Cosine angle A. We're still on the same angle, but now they want us to look at the adjacent side. Adjacent means next to. Next to. So, for cosine is the adjacent side to angle A and the hypotenuse. Okay, so here's angle A. What side is next to A? 4 and 5, is that correct? But 5 can't be adjacent because it's already labeled as what? So that means it has to be what? 4. And what is our hypotenuse? Because it says adjacent over hypotenuse, which is 5. And this becomes 0.8. And last but not least, tangent of angle A. See if you can fill that one by yourself. We're showing angle A, but they want us to do now the last one, which is opposite side over adjacent side. Turn over what you got. Very good. Good conversations. Yeah. 3 over 4, which is 0.75. All right, students, trigonometry students, good intro, yes? All right, let's move on. Agenda. Yeah, like I said before, the concepts are going to start coming a little bit faster now, so hold on to your horses, yes? Warm-up number 95. We are finishing up exponential functions, but you already took copious notes on this, so you should have all that already. But today I'm just going to revisit. And for home plate tonight, 4 transformations, and basically they're graphs. Once again, warm-up number 95 we just finished. We're still focusing on exponential functions. Tomorrow we're moving on. And your home plate for tonight, 4 transformations, which means the graphs only. Okay? No asynchronous code. Last time that I left you a home plate was when you did the artwork on Desmos. And after that we had a pop party and so on and so forth. Take your phones out, take a picture of that. That's your home plate for tonight. Basically, you're going to take the parent function f of x equals 2 to the x, and you need to do 4 transformations, which means I need 4 graphs on the same coordinate plane, 1 at each quadrant. Hopefully by the end of the review today, you should know how to do that, yeah? Yes, I think you will love these. All right, good. All right? All right, get a Cornell note ready, please. You do need a career model. Our objective for today, I can graph and write exponential functions. I can graph and write exponential functions. I'll give you some time to get your career model ready, your coordinate plane, your Cornell notes. Copy and go. All right, here we go. What are exponential functions? So here we go, exponential functions. They are a function written in the form f of x equals b to the x, or in the general rule form, g of x equals a times, parentheses, b to the and then exponent of x minus h, close parentheses, plus k, where b, or the base, cannot has to be greater than 0 but cannot be 1, and the x is a variable. Now also there, as a note, make sure you write in blue, right here for the letter B, write base. That's what we know as the base. And for the x in green, box it, that's what we know as the exponents. Exponents. Base and exponents. All right? Now, exponential functions. I gave you 2 basic ones to start with. In your notes, I'm pretty sure you remember, right? And here they are. F of x equals 10, base 10 to the exponent of x, and f of x is base 2 to the exponent of x. Those are the 2 parent functions that I've given you. From there, these next ones are already with transformations. So copy those. So I hope that you see that the obvious reason why these are called exponential functions, because the exponent is a what? Tell your neighbor. The exponent is a what? The exponent is a what? Mainly a what? A variable. Okay. So with that said, look at these non-examples. Don't copy them. Tell your neighbor why those two are not exponential functions. Tell your neighbor why those are not exponential functions. All right. So, why is this one not an exponential function, Zachary? It's not an exponential? Okay, good. Yeah, that's why I put it on the non-example. Help him out, please, Nicholas. The exponent is not a variable. The exponent is not a what? Variable. Okay. How about this one? Why is this one not an exponential function? Leo. It doesn't have the g of x or the equal sign. This is not a function. This is an expression. So, hashtag, it has to be a function. Hashtag, the base has to be a number, but cannot be 1. And the last one, hashtag, variable exponent. Variable exponent. And once again, you already have these notes and you already understand all this. I don't know why I'm going over it. So thank you for taking those copious notes. Appreciate it. All right. So, now we started at the beginning of the year with our general rule. Look at it. Don't copy it. You're like, oh, I remember, Mr. Q. I know, right? G of x equals a times f of 1 over bx minus h plus k. Do we know what each of those parameters does? A, B, H, and K. Yes? Yes? Okay, tell your neighbor what they do. What does A do to the function? B, H, and K. Talk it over, please. Really quick before I show you the next one. All right. So, and I said, guys, this is a general rule, and it applied to all the different functions that I gave you. Is that correct? Yes, Mr. Q. So if I was to give you now this applied to an exponential, which is that one, you know what each parameter does. Is that correct? Yes, Mr. Q. And Mario's got this one by, like, out cold, right? Yes, Mr. Q. All right, so what does H do on that one? Mario. Yes, this is the exponential function. But what does H do to the function? Help her out, please, Sebastian. Moves it left or right. That is correct. How about K, everyone? Up and down. How about A? Compresses or stretches vertically. How about B? Compresses or stretches horizontally. Same thing as the original, but now as an exponential function. However, copy this. Oh, not this one. Copy this again. And I want you to circle the letter or the parameter K. This is also our HA. HA. Tell you remember what that means. Good conversations, very good. Horizontal asymptote. Come on, guys, this is a review. We haven't even gotten into logs tomorrow. Bam! Let's go! Let's go! Alright, so that's our horizontal asymptote as well. Okay. So with that said, example 1, copy this. Write graph. And for this one, for the sake of time, don't make these tables, just the first one, and copy B, copy C. And B we're going to do in green, not red. B in green, not red. Alright, so example 1, it says graph. Part A, f of x equals 2 of x, exponent of x with the table here. Domain from -2 to 2. Part B, it's g of x equals 2 to the exponent of x minus 1. C in blue is g of x equals parentheses 2 to the exponent of x minus 1, close parentheses, minus 5. Get a coordinate plane from -6 to 6. I'll give you some time for that. Set it up, please. Copy and go. Alright. So here we go. Let's do work. I'm going to start with the parent function. I'm not going to write f of x equals 2 to the whatever number. I'm just going to write the base of 2. And instead of the exponent of x, what is my number here? -2. -2. It's right there on the table. Yeah. All right. So let's see how we did in practice with our negative exponents. What is 2 to the -2, everyone? 1 over 4. Let's go. See how that worked? Pretty good, right? Yeah. How about 2 to the -1? 1 over 2. How about 2 to the 0? 1. How about 2 to the first? 2 to the second? Then 2 to the third? 8. Alright, so here we go. I'm going to graph this parent function. First, we need to check and see if it has an HA, a horizontal asymptote. Look at it. Does it have a number at the end being added or subtracted? No, that means our y equals 0. So our horizontal asymptote is going to go through 0 on the y. There it is. Look up Mario. Next, let's plot these points. Here we go. -2 and 1/4. -2 1/4. -1 1/2. 0 1. Make this one bolder. I'll tell you why right now. 1 2. Make that one bolder. 2 4. Make that one bolder. And 3 8, which is somewhere over here. Bless you. All right. Exponential function with base 2. Okay. Pretty good, yeah? Yes, Mr. Q. Any questions? Does that look familiar? Yeah? Yeah. Okay. Now let's go to the first transformation in green. Look up. According to this one, what is our HA? Tell your neighbor, please. What's our HA? Does it have anything there? No, so it's still 0. It's right there. We already have it. Okay, there it is. However, notice that it's the same base, isn't it? So that means we're going to move this one according to this. Where to? Tell you now, where are we going to move it? Where are we going to move it, guys? One to the right. That is correct. One to the right. So all these points, I'm going to start with these three. One to the right. 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 And one to the right. Okay, next. I'm going to switch to blue. Look at this one. What is our HA? Tell your neighbor, what's our HA? Edwin, HA. Very good, -5. So we go to -5, which is down here, and our horizontal asymptote. But that means, notice, isn't this the same base as the parent function? Yes. That means we're going to take the parent function, which is this one in black, and we're going to move it according to what they tell us here. Tell you never where we're going to move it to. All those points we're going to move it to. All right, Jehu, go. Very good. 1 to the right, 5 down. 1 to the right, and 5 down. Hands if you got that. All right, some of you need to go to bed earlier. My goodness. 1 to the right, 5 down. I'm going to start with this one. 1 to the right, 1, 2, 3, 4, 5. This one. 1 to the right, 1, 2, 3, 4, 5. And this one, 1 to the right, 1, 2, 3, 4, 5. This one right here, 1 to the right, 1, 2, 3, 4, 5. This one is only 1 step back and half, 1 step back and half, and this one right there. There you go. So, we took the parent function, look up guys, we took the parent function, this one, let me highlight it so you guys can see it, I'm going to make it so obvious, because that's your home plate. We took this parent function, and we did some transformations, according to now how we know how to move everything else, right? So question. What if I asked you to move this parent function, which is the one in black, 3 steps to the left and 2 steps down? Think about it. 3 steps to the left and 2 steps down. So you never what that equation would look like. 3 steps to the left and 2 steps down. Three steps to the left and 2 steps down. We got it? All right, Jehu, pick someone. Leo. Equation. 2 to the x what? We said 3 steps to the left, 2 steps down. Very good. Plus 3. -2. Hands if you got something like that? Yeah, that is correct. That's basically what you're going to do for your home plate tonight. You need to rewrite it and then move it. You have to have one in each of the 4 quadrants. Yes? All right. So if I was to show you now the tables and all the work for the other ones, it would look something like this. Remember those notes that you took? Yes? Oh, yes, Mr. Q. All right, good. All right, copy this one. Example 2. It says graph g of x equals 1/3 base to the x exponents. Copy that table. Get another coordinate plane ready. I'll give you some time for that. Copy and go. All right, so you're going to fill in this table. Like I said, you already have these notes. Just for the sake of time, here's the work. Go ahead and copy that, fill in the table, and then we'll graph this one together. Copy and go. All right, so there's the work for the table. So here we have g of -2 is 1/3 to the -2, which became 3/2 or 9. There it is. G of -1 is 1/3 to the -1. The reciprocal is 3/1, which is 3, and so on and so forth. There's all the work right there. Okay, I'm going to zoom out. So let's graph this. This is a parent function, well, not a parent function, but for right now, let's leave it as g of x equals 1/3. Question: what is our HA? What is our HA? Tell me an error, please. All right. Marco, HA. What is it? Does it have anything at the end? Therefore, 0. So this is at 0. There it is. And with blue, I'm going to plot these points. -2, 9. -2, 9. -1, 3. 0, 1. 1, 1/3. 2, 1, 9, closer to the asymptote, and 3, 1/27. Very close. And what do you guys notice? That it starts high and it's starting to go downward. That's what we call decrease or decay. So, let's look at the previous one. What do you notice on this one? All of them started low and they went up, so this is known as increase or growth. They grow as we continue getting more values here. So this is growth. This is known as decay or decrease. So what do you guys notice from both? How do we know when it grows, and how do we know when it decays? Tell your neighbor, how do we know when it grows, and how do we know when it decays? Tell your neighbor, please. Did everybody catch that? Yes? When the base is what? When the base is a whole number, it grows, and when the base is a fraction, it decreases or decays. So check this out. I'm not going to ask you to copy this one again. You should have this table, but those of you watching online, you can copy this table. Just fill in each of the boxes there according to the general rule. But I do want you to copy this next one. Copy the general rule again, but now focus on the base. What did we say for the two different presentations today? That one was a whole number and it increased or it was growth. And the other base was fraction or decimal, it decreased or decay. So copy that, please. And of course, do we know what K is as well? Yeah, the horizontal asymptote. Copy that, please. Okay. So, let's see if we got this, just to make sure we can wrap this up. Here goes. Look up. What if I gave you the function f of x equals 10 to the x? Is that an exponential function? Yes. What base is it? Base 10. Okay. And of course that's going to look something like this. Why? Because it's a whole number, yes? Alright. Can we rewrite this one so that you can move it 3 to the right and 4 down? 3 to the right and 4 down. 3 to the right and 4 down. Tell your neighbor what that equation would look like if we move it 3 to the right and 4 down. 3 to the right, 4 down. All right, 3 to the right, 4 down. Justin, go. 10 to the what?
10 to x minus 3.
And then?
Minus 1.
Minus 4. Hands if you got that. All right. Let's go back to the original here. And let's move it 2 to the left and 6 down. 2 to the left, 6 down. 2 to the left, 6 down. Tell your neighbor the equation, please. 2 to the left, 6 down. 2 to the left, 6 down. All right, what'd you get? Mel. X plus 2 minus 6. Hands if you got that? Okay. So, from 1 to 5, how comfortable are you taking a parent function and moving it around in the coordinate plane from 1 to 5? How comfortable do you feel? 5 fours, 5 fours? Okay. Well, check this out. Turn the paper over. That's your home play for today. You have about 8 minutes. You should be able to do that one right now. Okay? And for those of you watching online, that's extra practice for you guys. So I'll give you guys time for that. And I'm going to stop the video. Have a good one. Bye.